Superstars! So today I want to show you a really cool concept in geometry. We have already learned about polygons, and we know that polygons are closed shapes that are made of line segments, and we are looking right now at a polygon that is called a rectangle. And so if you see the green line on the outside of the rectangle, we know that if we were looking for perimeter, we would have to measure along each side, and then we would add the sides up. But today I was wondering how much space is inside of this rectangle. And I realized that if I wanted to find out that, I would have to use a different unit of measure, because I'm not just measuring in a straight line. I'm trying to find out how much space is inside of this shape. And I know that that's two-dimensional, it's still flat, but I can't just measure with a ruler because that would be in a straight line. So I need a different unit of measure that's going to help me figure out how much space is in the inside of this rectangle. Now, if you notice, inside of this rectangle, we have all of these squares. And these squares are identical to each other. They're a perfect match. They are congruent, right? You know that word, same size, same shape. And I have all of them covering the entire shape. None of them are overlapping, and none of them are partial. They're all exactly a perfect square, which means that they're all the same size on all four sides. So I'm going to count up the number of squares inside this rectangle, and that's going to give me a new unit of measurement, which is called area. Area is using squares or square units to determine how much area is inside the shape. So let's count. You all know how to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I could say that the area of this rectangle is 18 square units. Area is the inside. Perimeter, remember, is the outside. So I've now figured out a new kind of measurement for my polygons. I can measure how much space is on the inside. So let's see how this applies to actually drawn figures. And you can see here that I have some giant grid paper. Grid paper is awesome for figuring out area. And I've drawn two really simple shapes here, two rectangles again. And I noticed that again, I have my outside shape, which could be measured in a line. So that would be my perimeter. That's not really what I'm interested in. I want to know how much space is in here, inside the entire rectangle. That's going to be my area. So I'm lucky to be using grid paper because all my squares are exactly the same size. None are overlapping. There are no spaces in between the squares. That's a very important concept for area. And now all I need to do is count them up. I'd like to show you a little strategy that I use for when I'm counting up squares in a big shape like this. I actually put a number inside of each box or each square so that I don't lose count, because that's something I'm always worried about. I always want to be accurate when I'm doing math. So I'm just going to put a little number in as I am counting. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's going to be a lot here. And what I'm doing is I'm making sure that as I write a number in each box, I know that I'm not going to lose count. I know that I'm not going to count too many. I'm not going to forget any. And I'm going to have a really accurate measure here. So almost being there. I'm now up to 35 boxes, which means that I have an area that's over 30 at this point. Let's see, I'm on my last row, and I'm all the way up to, let's see, excellent, 48. So now I know that every single box, okay, counts towards the area, and when I total them up, I have a total of 48. So I write it like this: area equals 48, which was the number of squares that I counted. And now I want to make sure that people know that I was solving for area, so I'm going to write square units after the 48. It's very important that I put what kind of measurement I was using. So my area of that shape is 48 square units. Now I'm going to show you a little shortcut that I can use for rectangles and squares as long as they are perfectly regular, okay? So I have 1, 2, 3, 4, 5, 6. Oops, 3, 4, 5, 6. 6 going across. And I have, let's find out, 12 going down. So I know, doesn't this look a lot like an array? It actually is an array kind of trapped inside of a rectangle. Well, I know if I wanted to know what this array was, I would simply say that it is a 12 by 6 array. So I took the length and I multiply it by the width, and I have to get 72. Okay? So now, if I use it like an array, I can actually pretend that this array is actually the area of my shape. So now I know that the length times the width is a shortcut that I can use to find my area. So the area of this shape is actually 72 square units. So I have found a shortcut that works really easily, just like using or finding out the total for an array, and I can use this when I have a rectangle or a square. So today you just learned a really cool new concept for our geometry unit, which is finding the area of a polygon. You try now.